Hi, my name is Eino Walden, and in this video I'll show you how to analyze trees from handheld LiDAR data. The data is collected using Hovermap laser scanner, which is mounted on a handheld platform. Tree analysis is done in TerraScan. I will use TerraScan automatic and manual tools to process the point cloud. The final product is a tree analysis report, which shows statistics such as tree height, trunk volume, canopy coverage, and so on. Some processing parts are sped up for demonstration purposes. I start every workflow with organizing project directory. I like to create folders for trajectory and saved point clouds. Then I create a CAD file from Terrasolid seed file, and then I can read in the LiDAR points. TerraScan automatically detects Hovermap as the scan system from the point cloud file. TerraScan asks to change coordinate setup automatically because the coordinate values are too large for fast computation. The recommended settings are good in this case. After reading points, I read in trajectory from the trajectory file. First, I specify the location where I want to store the trajectory, and then I select the file itself. TerraScan automatically detects Hovermap trajectory file format. Then I quickly get to know the point cloud and its attributes by viewing different visualization options. It is also a good idea to save the point cloud to fast binary format. This way I can skip the LAZ conversion next time I read in the points. Now it is time to classify the points. I have prepared a full classification workflow macro. I will quickly tell what steps there are, but going in depth is a whole video topic itself. I want to focus on tree analysis in this video. So to summarize, the macro links points to trajectory, deletes distant and overlap points, removes noise, classifies ground and points above ground, segments trees, and lastly, removes trees further than 50 meters from the trajectory. I also save the macro output if I want to see classification statistics later on. Now the point cloud is classified and trees are segmented with automatic tools. The first step of manual editing is to use inspect groups. This tool shows individual trees one at a time, and I can clean up wrongly classified or grouped points. I specify the tree class as the class that I want to inspect and set up the views. I want to view trees top down, front and right to get a good idea of trees' spatial structure. I set up display mode so that I have all trees visible in top view, but only the inspected tree visible in front and right views. Display set is used as filter to show only the inspected tree. The first manual tool is split tree groups. I can see that there are 2 trees in this tree group, and I want to split them into 2 groups. I can specify seed points which belong to each of those groups, and then the software automatically runs grouping again and splits the tree group. I am now using only one view to define the seed points. If the trees would be more connected to each other, I would use 2 views option from Add Seed dialog to specify the 3-dimensional location of the seed points even more accurately. 2-view seed point method is shown in our other video about tree analysis, which is linked in description. I recommend watching that video as well for another tree analysis workflow with TerraScan tools. Group ID number 2 has 0 points now in that group. It is because the points are now split into two new groups, and the new groups are at the bottom of the group list. Here I use the split tree group tool again. Now I'm splitting one big tree and smaller trees that are next to it. The next manual editing tool is Clear Group Fence tool. It allows me to clear the fence contents from the group. So in this case I will make a fence around the points that I want to exclude from the group, and the tool removes those points. This tool can be used to quickly remove points that are easily identified from the point cloud. And when you don't need to assign a new group for those points. Now I'm using Rotate Section tool to see the grouping from a different angle. This is a good way to see if you have only one view for front view enabled. This is a good way to see the spatial structure of the tree. It is also a good way to turn the point cloud so that you can easily draw the fence around points that you want to remove from the group. Here I have classic two trees in one group situation, and now I'm in a situation where it looks like the algorithm didn't work. I even run it again to see that is it really that the algorithm thinks that they are the same tree again. But that's not the case. The coloring is random, and it happened that the coloring assigned almost the same color for neighboring groups. But I shuffled the colors and it showed that the groups were different. Here I have a group where there is 3 trees. For that I can add one group to the split tree group dialog, and I can specify similarly as with 2 groups or trees, I can specify seed points for all 3 different groups. Then I shuffle the coloring to see that the groups are actually different. Now I change the viewing mode in TerraScan main window and see that there are some modifications to the imported point cloud file. I will save this point cloud file now to fast binary format so that I don't lose my work if I have to continue this, for example, on the next day. Now I use Measure Trunk Diameters tool to automatically detect tree trunks from the LiDAR data. The first diameter is calculated 1.3 meters above ground, which is the common value for diameter at breast height. Then I move on to manually edit the diameters. I inspect groups similarly as previously, but I now open diameters dialog from the inspect groups dialog. I also changed my front view from top right corner to diameter view so that I can inspect the diameters that the tool automatically found. I use the tool Move Section to go up and down the tree trunk and I use Place Trunk Measurement tool to place a new trunk diameter measurement. I can use the diameter field to specify the diameter value, and then I click the trunk to add a measurement. Now I inspect the worst diameter mismatches. I sort the tree groups by diameter mismatch so that I can check diameters from those groups and delete or replace bad measurements. Before I can export tree analysis report, I have to specify the group info format in TerraScan settings. These are the columns that will be printed to the output report. The report can be generated using Write Group Info tool under Group pull-down menu. Then you have to specify the file location, and then the software saves them as a text file. Thank you for watching this tutorial, and see you in the next one.